Hello. One of the most famous laws of physics is the law of Archimedes. You must probably know it. It means that if you have a body immersed into a liquid, then the liquid will make an effect, an upward buoyant force on the body, and by the law of Archimedes, this buoyant force equals to the weight of the liquid that the body replaces when getting immersed into the liquid. Usually we play around with water, it's the most common liquid on the earth. In this video I will show you an experiment which quite simple as this law, and will prove that this law is true. Now I explain the experiment and then I will show the experiment. Here is the plan for the experience. We will have a special setup. We will have a scale. On top of the scale we will have a construction, a frame, a simple frame, and a stone. A stone is hanging on a string from the frame. At the beginning there is no water around, only the stone hanging from above. What we are going to do is that an external person, me, will take a jar and will immerse the stone into the water, the jar full of water. The excess water will spill over and it will be collected at the bottom of the construction. The collected water will have exactly the same volume as the stone. And we will still have the scale underneath. What difference the scale will see? The scale will see that the force in the string, the pulling down force in the string, is not anymore the weight of the stone, which weight is, by the way, mass multiplied by the acceleration of gravity, but less by a certain force, which is the upward buoyant force, noted as Fb. So the scale will see less weight by Fb, but the scale will also see some excess mass on top of itself. And the excess mass is the excess water, which was not there before. And the mass, more exactly, the weight of this water is the volume multiplied by the density multiplied by the gravity. So the difference, which the scale will indicate, is plus the weight of the excess water minus the upward buoyant force. If we detect that this difference is zero, then we will know that these two terms are equal, meaning the upward buoyant force equals to the weight of the liquid which was replaced by the immersed stone. So we are going to execute this experience and we are going to check if the difference is really zero. And now let's see the experience which will prove the law of Archimedes. You see, we have the scale, we have the setup, we have the stone, we have the jar. It must be filled up with water fully, because the point is that the water spilling over should be exactly the same as the displacement water for the stone when it immerses into the water. And now I carefully will immerse the stone into the water. I should be careful to let all the water that spills over collect downstairs. And now, if you have a look at the scale, it's almost okay. By theory it should be zero. It's switching around this 2, 3, and now it was zero for a little bit moment. Although not fully exactly, but we were close to zero. And when I remove the jar, you will see that the scale shows 83 grams, which is the excess water collected at the bottom of the big can. So now you could see that we were really near to the zero. So the experience showed the theory, which exactly proves the law of Archimedes.